Good morning. My name is Sharon and I am from CSC AIML section C. Today my topic is bit conversion. Decoding data. Introduction to bit conversion. Welcome to this comprehensive guide on bit conversion, a fundamental concept in the realm of computing and digital information. In an increasingly data driven world, understanding how data is represented and transformed is more crucial than ever. This presentation will unveil the layers of complexity surrounding bit conversion, from the fundamental units of information to advanced representations and their real world applications. Prepare to embark on a journey that the digital language that underpins our modern technological landscape. What is a bit? The fundamental unit of digital information. First one is a binary digit. At its core, a bit is a binary digit, smallest unit of data in a computer. It can only hold one of the two possibilities, that is a 0 or 1. Think of it as a lighter switch, that is either on or off, representing states. These two states, 0 and 1, are used to represent information in electronic circuits. 0 might represent a low voltage and 1 a high voltage. The simple duality forms the basis of all digital information. Grouping of bits. Bits are rarely used in isolation. They are typically grouped together to form larger units such as bytes, that means 8 kilobits, 8 bits, kilobytes, megabytes, and so on, to represent more complex data like numbers, characters, or images. The simplicity of the bit's binary nature believes its incredible power. Every mail you send, every photo you view, and every line of code executed by your computer is ultimately broken down into a series of these fundamental O's and zeros and ones. Understanding the bit is the first step towards truly grasping how digital systems operate. Why convert bits? Understanding different data representations. While computers natively understand binary, humans often interact with data in most familiar formats like decimal numbers, alphanumeric characters, and visual images. Bit conversion acts as the essential bridge between these different presentations, allowing computers to process and display information meaningfully. Human readable formats. When we use base 10 numbers for counting, letters for communication, and colors for visual experience, these are all high level abstractions that need to be translated into the computer's low level binary language. Computer processing. For a computer to perform calculations, storage data, or execute instructions, all information must be converted into a binary equivalent. Without conversion, the computer would be unable to interrupt or manipulate our input. Interoperability. Different systems or components might have use varying data encoding schemes. Bit conversion ensures that you be seamlessly changed and understand across diverse platforms and applications. Efficiency and comprehension. Sometimes converting data into a different bit representation can make it more efficient for storage on transmission, often through various compresses techniques. Binary to decimal, the fundamental of numerical conversion. Converting binary numbers to decimal is a cornerstone of understanding how computers interpret numerical values. It involves assigning potential weight to each bit based on power of 2. The process explained. And example of 1011 binary code. This process reveals on how a seamlessly simple sequence of zeros and ones can represent complex number values, forming the bedrock of all digital calculations. Decimal to binary. How computers see our numbers. The reverse process. Converting the decimal numbers to binary is equally important. It's how our human friendly numeric inputs are translated into the machine's native language. The most common method is repeat by 2. Divide by 2. Take the decimal point and divide it by 2. Note down number which will be either 0 or 1. Current division. Take the quotient from the each step and divide it by 2, meaning this process until the quotient becomes. Collect reminders. Write down all the reminders in order wise from the last reminder to the first. This sequence of zeros and ones is your binary equivalent. Hexadecimal, a shorthand for long binary strings. Binary numbers are became quite long and cumbersome, especially when dealing with large amount of data. Hexadecimal base 16 provides a more compact and human reliable way to change uh, represent binary information. It's widely used in programming, may develop and memory addressing. In the base 16 system, hexadecimal uses 16 unique symbols that are 0 to 9 and A to F. Each hexadecimal digit corresponds to exactly 4 binary bits. Conversion efficiency. Conversion between binary and hexadecimal is straightforward because 16 is a power of 2 power 4. This means a group of 4 binary digits can be directly represented by a single hexadecimal digit. Example binary to hexadecimal, here it is given. ASC 1 and Unicode representing text with bits. Beyond numbers, computers also need to handle text, character symbols, and punctuation. This is where character encoding standards like ASC2 and Unicode come into play, mapping each character to a unique bit sequence. Practical applications from image files to network packets. Bit conversion is not just an academic exercise, it's integral to nearly every digital interaction we have. Understanding its practical application sheds light on the unseen mechanics of our digital world. Image file. Every pixel in a digital image is represented by a specific combination of bits, detailing its colors and intensity. Bit conversion is used to interpret these bits into the visual information we see. Audio encoding. Sound waves are converted into digital signals by sampling their amplitude at regular intervals. These samples are then converted into binary, forming digital audio files. Network packets. When data is sent across a network, it's broken down into small packets. Each packet contains information including destination address and data payload, all encoded in bits for efficient transmission and computer graphics. Common pitfalls and troubleshooting bit conversions. While bit conversion is fundamental, it's not without its challenges. Misunderstandings or errors in the conversion process can lead to corrupted data, incorrect interruptions, or system malfunctions. Being aware of common pitfalls is a key to effective troubleshoot. The first one is Indian issues. Second one is layoff one error. Third one is character encoding mismatches, and fourth one is data truncation. Key takeaways: mastering bit conversion. Uh, Bits are the digital building blocks. Conversion brights human and machine. Hexadecimal offers efficiently. Encoding standards enable text. Applications are ubiquitous. Thank you.